right, in this video, I'm going to talk about binomial distribution, and we're going to do that with an example of flipping a coin 10 times. So if we were to flip it 10 times, let's say the scenarios where it would land on heads 5 times. What's the odds that that would happen, where we'd have 5 heads and 5 tails? What would be the odds that it would land on heads all 10 times, and we'd have 10 heads and no tails, right? So those questions, that's what binomial distribution is going to answer. So what we're going to do here is we're going to first do this long form. We're going to plot out every single possible scenario for those 10 flips. Then going to calculate the likelihood of each of them. We're going to summarize the outcomes in a table over here and get the percentages. And we're going to see that those percentages we get are going to perfectly match this BINOM.DIST function inside of Excel. So we're going to draw comparisons there. Then we're then going to get into exactly how the BINOM.DIST function works, and then we're going to talk about the math problem behind the function so that we can understand what's going on behind the scenes. So the first thing we're going to do over here is we're going to plot out all of the possible outcomes. Now you may be looking at this and saying, that's a lot of outcomes. Am I going to have to sit here and type all of these outcomes? That's going to take me forever. The answer is no. There's a real simple formula. We're going to talk about just from the ground up. We're going to start with the basics of how to build this formula, and then we're going to apply it here and get all of our scenarios in a really quick and efficient manner. So here are some index columns I want to show here and the formulas that will create them. The ones we're going to be using, the one on the right is the one that's going to be used. The one on the left are two that might be useful I want to share here. It also shows how to use the roundup and the mod function, both of which we'll be using. You can see both of those are used over here. On the one on the far left, you can see it does a normal count, but then we have it resetting after a certain number. You can see that certain number is 3, and the second parameter is defining that restart point. I'll talk about how that works in a minute. Over here, we have a different type. The roundup one is only going up by 1, and it's never resetting, but it's holding its value until a specific point, and then only going up by 1 after that nth value. So nth in this situation would be this number right here after the dividing sign would be 2, so it's holding it 2 places. It's having 1 2 times, 2 2 times, 3 2 times, etc. So we'll talk about that, and then we're putting it all together over here, and you can see this is what we're going to use. 1s are going to be heads and 0s are going to be tails, and we're going to manipulate this to give us all our columns. All right, so let's go ahead and apply these formulas and see how they're created from the ground up. So down here at the bottom, I've got 3 columns. The first one's roundup, second one's mod, the third one's combined. On the far left, we're going to have a column. This is just going to be an index column. What I'll do here is I'll type sequence. We'll say do it for 10 rows, go to 1 to 10, and then we'll just list 1 for the second and third parameter there. So to apply the roundup, what we'll do first is we'll retype that sequence out. And we'll divide this by 2. You can see what's going on there is it's now giving a decimal place for some of these. 0.5 for the first one, 1 for the second, 1.5. What we'll do to this is we'll come in and then wrap it in a roundup. We'll put 0 as the second parameter, and you can see that's the catalyst. That dividing and then rounding up is the catalyst to allow us to control at which point it goes up in value. So if we come up here where we divided by 2, this is the place where we will control how long it holds that value. This can be thought of as the nth value that you see in a lot of literature. And the N is in Nancy, they'll say the nth value. So we'll control that here. If we wanted to say 3, it would hold it 1, 2, 3, and then go up by 1, 1, 2, 3. We could change that to 5, we could change it to whatever number we wanted. That's what it's going to control there. On the mod function, a little different here. We've got starting with the same formula here, 10, 1, and 1. But let's come over here and wrap this in a mod function. Say mod. What a mod function is it's asking it, is there a remainder being a decimal place, when we divide by this number. This number is controlled by the second parameter here. You can see that's the divisor right there. So we're going to say 2. And so what it's asking is, it's saying, when we divide 1 by 2, is there a decimal remainder? And the answer is yes, because 1 over 2 is 0.5. The remainder there is 0.5. 2 over 2, no, there's not, because that's 1. There's no decimal there. So it's 0. It's going to do that all the way down. So that's what allows us to have this reset action there. What we're going to want here is we're going to want this layout here, but we're going to want it to hold this 1 or 0 for a specified period. So for instance, in the first one, we're going to have it do heads for the first half and then tails for the second half. So that's going to be a value of, you can think of it as a value of 1 for the first 500 and some odd numbers, and then a 0 for the next ones. So we have to do a combination of these two. So what we're going to do is we're going to come and grab the roundup here and start with this formula. And then all we're going to do is we're going to wrap this in a mod function. We're going to say 2 here. And you see that stretches it out now. We've applied this roundup concept where it's holding every nth value to this formula over here under the mod. And we can control how long it holds its value by changing that number under the dividing. So we change that to 3. Now it's holding it 111. Change it to 5, whatever the case may be. So that's how we get that. We're going to take this formula and we're going to build out on it over on the Excel sheet. Before we begin, we need to understand how many different outcomes are there with 10 flips. So to see how this works, if we come here and we flipped it one time, there would be 2 different possible outcomes, either heads or tails. If we flipped it twice, there would be 4 different possible outcomes. One outcome could be they'd both be heads. One outcome could be they'd both be tails. The 2 in the middle would be some sort of either heads, one is heads and one is tails. We come down here to 3 flips, it grows to 8 different outcomes. You can see all the outcomes there. So the takeaway here is that we can calculate this by doing 2 to the power of however many times we plan to flip it. 2 representing the possible outcomes, either heads or tails, and then the exponent representing the number of times we're going to flip it. So we can get the answer by doing 2 to the 10th power. If we open up the calculator and do that, we can see there's going to be 1,024 different possible outcomes for flipping a coin 10 times. All right, so the next part is to build out this Excel sheet showing all the different outcomes that are possible for 10 flips. You see here I've brought over the formula. We'll use that in a minute. Up here, build that out. First, what we want to do though is we want to create just some initial things. The first thing I've done here is create a variable. We're going to make this dynamic so we can just change the number of flips and all the data easily by entering however many times we want to flip the coin right here into C1. The second part of this, we want to create the rows. The first part of it is having that index column that numbers all the different types of outcomes and counts it up. How we'll do that, right here below outcomes, we'll say equals sequence. And instead of putting 10 here, we'll put however many outcomes there are. And remember, we can calculate that by doing 2 to the power of however many flips. So we'll say C1. We'll hit F4 to lock. And there's a index with going from 1 to however many possible outcomes there are. Second part of this is we want to have numbers up here on the column side showing how many different times we flip the coin. To do that, what we're going to do is come to E2 works fine. We'll do that right here. And we'll say the same formula here, sequence. What we'll do here is, because we're flipping it 10 times, we'll say C1 for that first parameter. Then we'll say 1 for the second and third parameter. Now you see that's going down in a column. So how we'll get that to go horizontally is we'll wrap this in transpose. No second parameter needed. We'll just wrap it there. You can see that makes it going across. All right, next part, we're ready to start on the columns here. And so what I'll do is I'll come up here and grab this formula. And right below the 1 here on 1, 1, I'm going to do the let function. What this will allow me to do is declare variables. It'll make the formula a little easier to read. I'll hold down Alt and Enter. So what it'll allow us to do is we can basically take chunks of the formula and assign it just a variable name. So what I'll do here first, I'll paste this in. And what we want to do is we're going to want to change this 10 here and this 2 here. And so what we're going to want to change this 10 to is the total possible outcomes that are possible based on the number of flips. So I'll name it total possible outcomes. And then remember that is 2 to the power of whatever's in C1. Hold down Alt Enter again. The second one will be just the reset point. That'll be the number after the divisor. And so what we're going to want to do here is, so there's 1,024 different outcomes. On column 1, we want the first half to be heads and the second half to be tails. So we want the first 512 to be heads, the next 512 to be tails. We're going to see that pattern repeating over every single next column. So on the second column, we want the first, whatever half of 512 is, let's see, 256. We want the first 256 to be heads, then we want the next 256 to be tails, the next 256 to be heads, the next 256 to be tails, and it's going to divide by 2 every single column. And it's going to be like that. So the easy way we can do this, we can divide by 2 if we wanted to, but the easier way to do this is just to do 2 to the power of the number of flips, F4, minus whatever flip we're on currently. I'll keep that unlocked because we want that to change, but I will wrap both of those cell references in parentheses, comma afterwards. And then we can come down here and fill in, instead of 10 here for the first parameter on sequence, we'll put total possible outcomes. And then next to the dividing sign, we'll say reset point. All right, doesn't like parentheses, it'll automatically adjust though. All right, and so what we should see here is if we go down, we'll see 1 stretching all the way to 512. Yep, so that's good there. So what we can do next is we can do an if statement here to change it from 1 and 0s to heads and tails. So I'll wrap it if the formula for parameter 1, parameter 2 will just say heads, parameter 2 will say tails. Let's see what it doesn't like here. Get rid of one of these. All right. So if we come all the way down now, we'll see heads. And I've put some conditional formatting there. How we'll do the conditional formatting is we will highlight all 10 of these all the way down to the bottom. Come up Home tab, conditional formatting. Under highlight rules, we'll say equals to. We'll say heads, and we'll choose that to be green. We'll click OK, and then we can do the same thing with tails for red. I've already done that, so I'm not going to finish that, but that's how you'll do the conditional formatting. One last adjustment that needs to be made to the formula here. We'll come up here. Whenever we change the flips and it goes blank, we want all of these other cells to be blank. We don't want them to default to heads. So I'll wrap this, I'll say if, right at the beginning. I'll say the len function. I'll click on the coin flip number right above the column. If that's greater than 0, meaning if there's a number in there, then do this formula. If not, then be blank. I'll do 2 quotation marks right there. I'll adjust the parentheses. There we go. So now we are good to drag this all the way across. And there we go. We have all the possible solutions. Come up here and change this to 5. You'll see that automatically adjusts. Now we don't want to be more than 10 just because of the way I've set this up. It's going to spill over into there. But that's fine. We're only going to look at 10 here. But you can adjust the formatting around if you wanted to see more. So right here, likelihoods and heads. What we first want to do is we want to measure how likely is each outcome divided by all the other total outcomes. So here we want to say if a number is in this outcome column, then what we want is 1 divided by the total number of outcomes. So that would be 2 to the number of flips there. I'll hit F4 to lock that. Otherwise, we don't want it to show anything, so that would be right there, 2 quotations. That gives us that. We'll highlight this. Actually, we'll highlight the entire P column, change that to a percentage. There's the percentage there. So each outcome has a 0.0977% chance of occurring. Over here on the heads, we want to count how many heads are in each of these outcomes. And so how we'll do that is we'll say equals COUNTIF. We want to count this range right here. What do we want to look for? If it says heads. Okay. Now there's no way to make this dynamic like we have all these other ones. So we're just going to have to drag this down. Okay. And then if we wanted to do more than 10 flips, we would have to drag this down even further. For the time being, though, we're not going to do any more than 10, so I'm going to leave it like that. So that counts the number of heads there in each of those. Over here, we have a summary table. And so I've added all of the possible number of heads for in all these outcomes. We want to count how many of these outcomes has no heads. That's going to be 1, right? There's only one outcome where all 10 are heads. But then how many of these outcomes have 5 heads? That's going to be a lot bigger. How we'll do that is we'll say COUNTIF. We'll highlight the Q column here. We'll say, what are we looking for in there? We're looking for 0. So it'll count how many times 0 is in that column. It returns 1. So we can drag that down. There we go. It's counted up how many times, how many outcomes had, for instance, 5 heads in it. There's 252 different outcomes that had 5 heads and 5 tails in it. Next, what we want to do is highlight all of this and the cell right below it. Come up to the Home tab, hit Auto Sum. That's going to give us our total number of outcomes, 1,024, and that's correct. And then finally on the summary table, what we want to do is come over here and figure out, all right, of these outcomes, what is the likelihood that we'll have no heads? What is the likelihood we'll have 5 heads, right? 252 different scenarios, so that one's going to be bigger than any of these other ones. How we'll do this is we'll hit equals this, divide by the total number, 1,024. We'll hit F4 to lock. And I messed up the parentheses there, but it's good, automatically corrected it. So we'll drag this all the way down. And we can see there we go. There are the percentages, the likelihood that we'll get 5 heads when we flip the coin 10 times is almost 25%. The likelihood that we get anywhere from 4 to 6 heads is, see down here, 65%. So we have a 2/3 chance that we're going to get either 4 heads, 5 heads, or 6 heads when we flip a coin 10 times. On the flip side here, one of these extremes where we have all tails or all heads, extremely unlikely, 0.10%. So what we can do next is we can graph this into a bar graph. We'll highlight all of the outcome percentages, come up to Insert, click on Column. Let's do the 3D column. That'll plot that. Now we need to make some adjustments here just for visual purposes. So the first thing we need to do is we need to come correct this, because you can see these are wrong down here. So we'll click on the graph here. We'll come up to Chart Designs, select Data. Over here on Horizontal, we'll click Edit, and it'll highlight the number of heads over here. Click OK, and that updated it there. So now far left shows 0 heads, far right shows 10 heads. And then I'll plot in here the percentages by left clicking on the bar one time. That'll highlight all of them. Then we'll right click, come down to Add Data Labels, and I'll add the percentages right above. Another thing we can do, we'll click on the chart here, come up to Chart Design, go to Quick Layout, Add Chart Element is what we want. Come down to Legend, click None, I'll get rid of that legend. And then if we want to make these a little bigger, we can right click on the numbers, go to Font, just increase the font size to 10, and we'll do bold. All right. And so there we have a chart that shows the odds that we're going to end up with 5 heads, 6 heads, 7 heads, whatever the number is. This is the binomial distribution that we're looking for. Now Excel has a built-in function that will give us these numbers by just entering in the function. What we'll do is we can come up here, off to the right, I'm just going to enter it in here. I'll click equals, type in binom. See that first one, BINOM.DIST. Gives us 4 parameters here. So if we come over to Microsoft documentation here, it describes exactly what these 4 parameters are. First one, the number of successes and trials. So this is going to represent, in our situation, the number of heads. Trials, the number of independent trials. This is how many times we flip the coin. The probability of success in each trial. So this can be adjusted in different scenarios. For our situation, it's going to be a 50-50 chance. If we had, let's say, a coin that was loaded to land on heads more often than tails, that's when we would change this. Let's say it was sort of weighed somehow to land on heads 67% of the time. We would change this to 67%. We can look at how that'll change things. Then we'll get into what this cumulative is down here. For the time being, we're going to say false though. So we'll come over here, we'll say number of heads, that's going to be 0. The total number of flips, that's going to be 10. We'll hit F4 to lock that. Our percentage is going to be 0.5. And for the time being, we're going to say false. We'll drag this all the way down. And you can see that we're getting the same exact numbers that we got over here. Now let's look at what happens if we were to change that percentage from 50-50 to a different number. So right here, I'm going to copy this. Right here in this column, I'm going to paste it in. I'm going to change this 0.5 to 0.67. And you can see the adjustments here. That larger percentage is on 7 now. We've got the larger ones on 7 and 6, which makes sense because we've said 67% is the expected rate of success. Whereas when we were 50-50, that larger percentage was on 5 number of heads. So let's look at the difference between that 4th parameter being false and true. So we can see here on the 50-50, 20.51%. That's saying that there's a 20.51% chance of the outcome being 4 heads and 6 tails. If we were to take these formulas though, copy them, I'm going to paste them over here. I'm going to change that last one to true. And we drag this down. what we'll see is these larger numbers at the bottom. What this is indicating is that, let's see, I've written down here, the chance x, whatever number we're talking about, so in this case 4, 4 heads or less will be seen. So saying 37.7% chance that the outcome will be 4 or less heads in our results. If you were to take these outcome percentages over here and add them all up, you would see that totals to 37.7. So that's the difference between the true and the false here. Whereas false is only looking at this one specific outcome, true is looking at outcomes for this one and the ones before it. Now we can adjust this to look at the ones below it as well by coming in here, and instead of just doing this binomial function, we can do 1 minus that number, drag it down. Now what this is saying is the chance that an amount of heads less than whatever number we're on, not including this current number. So you can see here for 4, that's going to be 62.3. So if we were to highlight 5, 6, 7, 8, 9, and 10, that would add up to 62.3. And we can do the same thing for 67% here. Came over here and change this to true. And made this percent. You can see that in that 67%, there is a 69% chance that it will have a result of 7 heads or less. We can add that up by coming to the 7, going all the way up, 69.3. Then again, that 1 minus, drag that down, that would show under the 7 here, that would show a 30% chance that we're below 7, so it would be 8 heads, 9 heads, or 10 heads, 30% chance, and that adds up perfectly there. All right, so this is the formula it's using to calculate the percentages. We'll go over exactly how this works, but this exclamation point right here is a factorial, so it's calculating if n is 10, it's going to represent the number of flips. It would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right below it, k, that's going to represent the number of heads we're measuring, and that's going to be just simply doing that same concept. So if we're looking at 7 heads, 7 times 6 times 5 times 4 times 3 times 2 times 1, and then we times whatever that number is by n minus k factorial. So it's going to be 10 minus 7, which would be 3. So we do a 3 factorial there. Let's look at this right here. I've put it out into Excel, a little more difficult to read, but I think that it's easier to explain. So we've got total flips here, as we discussed, times number of heads we're measuring, factorial, times the number of total flips minus the number of flips we're measuring, factorial. We then times that, whatever that number is, by the percent probability of heads. So if we're doing a normal 50-50 coin, it would be 50% to the power of the number of heads we are measuring. So if we're looking at the situation where we have 6 heads on the outcome, then we would raise it to 6 times 1 minus the probability of the heads. So this would be, if it's a 50% coin, this would also be 50%, and then raised to the power of total flips minus the number of heads we're measuring. So if we're doing 10 minus 6, that would be 4. And so down here, I've added 3 variables, and we can adjust this around. Let's look at 50% first. So if we were to do 0 here, we would get 1 here for this, what is termed the binomial coefficient, this first part here. We're going to get 1 times 50% to the power of 0, which would be 1, times 50% to the power of 10, which would be 10. So we got 0.10%. You can come over here and see that measures out. We could change this to 5 here. See that adjust to 24.61. Exactly what we got there. So that's the structure it's using there. I'm going to do test one more, 7, 11.72, and that matches up. So then we could change this. If we change this to 0.67, you can see for 7 heads, the number is 26.14. And you see that's the number there. So that's how it's calculating it. A little bit of a complex formula, but pretty simple once it's sort of written out here. All we're looking for is just that percent probability. So if it's 67% and 33% in this situation, it's going to be 67% there, 33% there. Then how many heads are we measuring? If we're measuring 7, we're going to put 7 there, 3 there. To do the factorials in Excel, I'll show how you can do that. They have a formula called fact. That'll be the factorial, and we just put in whatever number. So if we want to do the factorial of 10, which would be 10 times 9 times 8, etc., you would just do fact, put 10 as the variable, and then that's going to calculate that number for you. All right, so that's going to conclude everything I wanted to show. As you can see here, if we were to flip a coin 10 times, we have the results here, the odds that how many times we would land on heads. Like we discussed, 67% would be in the 4 to 6 range. But the real takeaway here is how to use this BINOM.DIST function inside of Excel. So a little context around how it's calculating these numbers, and if we wanted to get these numbers in a quick and efficient manner, it sort of highlights how we can use this and have some confidence behind the number that it returns.